Hey, Sean's here, and this will be a quick guide on how to quickly set up VS Code for C development in a Linux, Ubuntu distro. For other stuff, it's a little bit simpler, but for this, it's not as like complicated as you might be thinking, but it is a little bit more involved than just setting up, say, Python. So, first thing we're going to need is, a compiler like GCC. Usually, most Linux distros come with it pre-installed, so you shouldn't need to do it, but just in case, just check if you have it. If you do have it, you'll see a message like this printed to the console there. If you do actually need it, then you want to update your update repo really quick. Then you're just going to run this, and I already have it, so I'm not going to, of course, do that. Not even worth bothering. Then you'll need the dependencies and libraries for C development, and you can get that with build essential. And run that, and it'll get you everything juicy that you need. Then you'll need a tool to actually build and run the binary executable program that is built with CMake. Or I kind of spoiled it. And what I use is CMake. There's other ones that you can use, but this one's pretty popular, has a lot of support. So this is what I use, what I recommend. And we're pretty much good to go. You can actually get into VS Code and start actually creating everything. So we will just do that. And then you can use the GUI if you want. I'm going to use the terminal for most of this. But first, really quick, just talk about extensions. Good to get the CMake tools extension here. Just download these top two. They'll have the most downloads and everything, so you can know they're pretty trustworthy. They also are made by Microsoft and this dude right here. And then, you can get other stuff you want. You can get stuff like stuff for specifically C development. Download those. These are good to get. I personally have them, personally use them, but you don't need them. So it's up to you. And we'll close that and go back to File Explorer. So again, we're going to need a directory to actually make our project in, and this will be referred to as the root project directory. So we'll make that really quick. We're just call this practice. I like to just list anything after I've made something. So we're going to cd into practice. And I do that again out of habit. So now we need to actually tell CMake where everything's going to go, what it's going to be called. We're going to need a CMake list.txt. So we'll make that really quick and make sure that it is spelled out exactly how I have it listed here. List that. We can see that we have it there. I will include a link to my GitHub in the description below. And it will have, back to repos right here. It'll have a README that will have pretty much the transcript from this video, and you can look through really quickly, see if you missed anything. But you can just go into here, copy this, go back here, and then we'll open up CMake list, paste this in. And so you're going to put in the second line here where it says project, you're going to put the name of the directory, which again was practice. You can see right there. And then this line, add executable. So the first argument is going to be what you want the executable to be called. So that's going to be what we actually run once the program has been built. So we're going to call it hello world for consistency. And the C file I'm going to make is going to be called hello world.c. And this is basically the point where you actually make your program. So you would want to touch, what do they call it? Hello world.c. List that out, and you can see it in the file explorer there. So we're going to open up hello world.c, and we're just going to quickly make a hello world program. Include these. I just include, even though I don't need both, I just do that out of habit. So standard in and out header. So we have both. Then we're going to make, well, actually I'm going to do this just to show you guys something. So we're going to make it void actually, and then printf. Thank you, GitHub Copilot, but I don't need your help right now. That, and we'll return 0 because we like to return things, right? Like to tell the person that we got a value too. So now that that's done, now that we have our main C file created, we actually need a build directory for CMake to build from. So we'll make that really quick. Make their build, cd into it. I spelled it. Let's make sure nothing's in there already. Okay, so we have our build directory. So basically everything we need to do now can be done for this directory, so we don't need to cd out of this again after this point. So I'm just going to run cmake ... and that'll run it from the root project directory. That's essentially equivalent to if I actually change directory back to the root project directory, which again is practice here in this context. But again, we don't need to actually leave build do that. That's why I'm just doing this. And you'll see it build the necessary files and write them to the directory that we're in. And you can see in the file explorer here that everything's listed there. It has everything that you need. Don't need to worry about all that. All you need to do now is just run make from the, again, make sure that you're running make from this build directory right here. And make sure again that your cmake list is in the root project directory along with your main C file. So again, all you need to do is run just make. That's it. And you'll see that it was successful in building everything. This is pretty much good. All this green stuff here, you want to see that. You can see there was a few compiler errors, but it still built it because these compiler errors don't actually affect the running of the program. But it still gave you the feedback there because we tried to return a value from a void function, which of course doesn't return values. So with that knowledge, we can either get rid of this return statement, or we could just change this to int and then add this back if we wanted to do either or, and we'll save the changes there. And you can see that I saved the changes and everything, and I built the program. But if we actually run the program that we made, we're in the current directory, you'll see that I forgot to put the O there. That's very important. You don't want to go to hell world. Hell world is not good. But again, this is still basically the previous thing. You'll see that even if I add that back and run the program again, we're still in hell. So that's not good. We don't want to be in hell. We want to get out of hell. So we're going to have to go ahead and make the program again. And you can see that this time when I made it, I didn't get that compiler warning about the function not returning anything because it was void, because we already changed everything and we are returning 0 now as well. So just keep that in mind. Anytime you make changes like that, you need to make it again with the make command. And you can see that when we actually run it. Oh no, I'm still in hell world. What did I do? Where did I mess up? Did I not? Let's see, build target hello world. Still in, I can't escape hell world, guys. What's going on here? Where did I mess up? That's good. That's good. Let's just run a clean build. And sometimes you might have to do things like this. This is always the fun of programming. So let's make it over again. We'll target hello world. There we go. Okay. All right. And you have to see a little bit of troubleshooting there, so you might have to do stuff like this. So just keep in mind that sometimes you might have to actually fully remake everything with cmake ... from the project directory. So just keep that in mind. You do actually have to do that every time you clean the project as well, which is something else I won't really go into. That's beyond the scope of this video. So just keep that in mind. You might have to fully remake the project to build it again correctly. And you can see that all this is done. And also we'll just do this because I hate seeing it on the same line like this. So we'll just add a new line, make it again, run it again. Let's just do this. And you can see that it actually printed it out on its own line this time. And yeah, that's basically how to set it up, how to get going, how to make your first project. Hope this was helpful in solving any issues you might have had getting this set up, and hope that your coding journey in C goes well. Peace out, and